Hello everybody, did you know that the name of an array is pointer? Well, look, normally when we create, for example, an array that size is 3, and for example, short int zm, and now, if we look into our memory, it would look probably like that. Of course, it could be in another place, and it would be of course bigger, but somewhere in our program there would be 3 times reserved for bytes for integer, because integer is reserving 4 bytes. And as you can see, after it we have the zm, the shorting because it's reserving 2 bytes. It doesn't need to be next to each other, the zm and the array, but they can be. And the most important thing here is that you should notice that array is always continuous. That means that they are next to each other, okay? So it means that if we could point to that guy here, to that 0, we could jump 4 bytes later and we would meet the second element. And then again I could jump to 4 bytes later and I would meet the third element, right? Okay, now let's see how it's working. For example, I will send to the output right now the A here, and then I will send to the output the address of first element in an array. And as you can see, both addresses are the same. It means that this guy here is a pointer, right? Because if I did something like that, int pointer, now I will assign here address of first element, you would notice that by sending something like that to the output, we still have the same address here, right? So the name of the array is a pointer. In addition to this, this pointer is also here constant. It means that we can't change, for example, the address here. So I had, for example, something like and now I would like to do something like that. No, we can't do that. We can't do something like that because it's constant, okay? We can't change the address here. Okay. Now let's send to the output all addresses of the array here. You will notice that they are moving by 4 bytes. So they are next to each other, right? 0, 4, 8 at the end here. If you had, for example, double here, I change here also double type, they are moving by 8 bytes, right? 0, 8, and then 2, 3 in that position. Okay, let's go back to the integer type. And now I'd like to show you something. Let's make some end lines here so it will be easier to read. And look, I will send to the output A, and then I will send to the output something like A plus 1, and then A plus 2. And as you can see, the values here are the same. 30, 33, 4, 38, and here are the same, right? So we can move here by using the pointer, by using the sign plus, right? The +1 here. And the +1 here doesn't mean that I want to move by 1 byte, but I want to move by 1 position of the size of that pointing variable that we point to right now, right? So for the integer, it means that we want to jump by 4, jump by 8. So it is like 2 multiplied by 4 here, something like that. Okay. Because pointers are intelligent, right? They know what they are pointing to, because it says here. So they know that if they meet something like +1, they have to jump by 4 bytes when it's integer. Okay. And now, what is cool, we could do something also like that. Because it's address, we can get value from that address by using the asterisk, right? Like I told you in last lesson. So I can do something like that easily. And now, we have here some random values because we didn't assign anything here. Let's assign here a few values. For example, 20 and 40. And as you can see, it's 0, 20, and 40. So we can do it that way. Or we can do it that way. So this notation is going to give the same result as this one. As you can see, everything works fine. Okay, I told you we can do something like that. Why? Because a++ is going to do the same thing like a equals a plus 1. So it means that I want to change the address of first element of that pointer here. And that pointer here, as I told you, is what? Constant. But, let's see, as you can, if you see, it's not working. But we can do easily another pointer, for example, integer, and let's call it, for example, p2, and assign here address of first element here in the array. And now we won't just type here constant, but we'll just remove that. We'll just do that, something like that. And now we can easily send to the output something like that. And then we can also do something, for example, like that, or like that, or like that. Okay, and all that pluses here in different positions means different things. If you don't understand the pre-incrementation, post-incrementation, please go to the arithmetic lesson, because it will be very important to understand it here. And now, what should we see as a result here? So here we are getting the value, we are retrieving the value that is under the address that is pointed here. So it will be what? 0, right? Okay. And then what we are doing? We are first incrementing the value that is under that address. So it means that here we will increase what? The value that is here, right? So it will be changed to 1. So here will be 0, here will be 1. And here we are doing what? We are we want to get the value from, and here we are doing something like let's move by 1 array later. So we are moving 4 bytes by 4 bytes here. Because pointer is intelligent, right? Like I told you. Now we are moving by 4 bytes. So here, move by 4 bytes and show me now here the address of next guy. Because we were pointing here at the first element. After that instruction here, we are going to point at second element, so that guy here. And we'll have here 20. Okay, what about that guy here? Here, I want the value from the current pointed address, right? So, right now it is 20. So we will send to the output 20. But after it, we are also increasing again, what? The address by 4 bytes. Because we are increasing address by 4 bytes. In next line, that guy here will be pointing to the address of that element of array. So we'll get here the value 40. Let's see if I'm not lying. As you can see, everything is working like I told you. 0, 1, 20, 20, 40. It might be a bit confusing at the beginning, but train a bit and it should be fine. Don't worry about it. So right now we are pointing to the last guy right here. We are pointing to the last guy of an array, but still we can jump. For example, we can do something like that later. As you can see now, I have here 2, and we can jump again. That values here after it are random. We don't know exactly what will be there. We are right now pointing on to the memory that might be used in our program, or it might be also something from another program. That's why we should be careful with pointers, because when we try to change something what is outside of our program, the variable that is used by other program, our program will stop running, because it's not a secure operation and it will be stopped. Okay, that's all in that lesson. We'll talk about cooler things in next lesson that will use the informations in that lessons. Okay, that's all. Thank you very much.